Let us discuss area under the normal curve, that is normal probability integral. In this, the conversion into standard normal form. First, here we can take by the definition of the probability in the normal distribution, f of x such that mu comma sigma is equal to 1 by sigma root 2 pi integral minus infinity to infinity e power minus z square by or minus x minus mu whole square by 2 sigma square dx. This is the probability distribution function in the normal curve. Here we can take z is equal to x minus mu by sigma. From this, x minus mu equal to sigma z. In this, by taking z equal to x minus mu by sigma, then the standard normal curve is formed. Here, the total area of the curve, we can take the total area of the curve in the normal distribution, that is equal to 1. That is minus infinity to infinity f of x dx is equal to 1. The area under the curve is divided into two parts by z is equal to 0. It is z is equal to 0. The left side is the minus infinity. The right side is the plus infinity. The from z to left side is, that is the part is 0.5. From the right z to z equal to 0 to plus infinity is, that is 0.5. The total area is 1. Okay. Here, the probability that random variable capital X will lie between x equal to mu and x equal to x1. It is the sum. We are taking x equal to mean and x equal to x1. Then it is given by probability of mu is less than x is less than x1. Then we are taking by the definition of the probability in the normal, that is integral mu to x1 f of x dx. It is equal to 1 by sigma root 2 pi integral mu to x1 e power minus x minus mu whole square by 2 sigma square dx. From this, we can take and we can convert into standard form by taking z is equal to x minus mu by sigma. Here x minus mu by sigma means, in this we can take the limits z x is equal to mu, then that is the left limit. From this, the z1 becomes mu minus mu by sigma is equal to 0. And another one is x equal to x1, then z2 is equal to capital X minus small x. Here, in the place of x equal to x1 minus mu by sigma, this is equal to z2. These values substitute here, that is 1 by sigma root 2 pi integral. In the place of x substituting mu, then we are getting the lower limit is 0, the upper limit is suppose z1. Then e power minus z square by 2 sigma dz. The sigma get cancelled. We are getting 1 by root 2 pi integral 0 to z1 e power minus z square by 2 dz. It is the even function. Then this integrand is called as area of z, that is 1 by a of z1. Here, A of Z1, that is area of Z1. Why? Because it is from 0 to, here the area is, it is Z equal to 0 to, from 0 to positive value means it is Z1. Then this is called as the area of Z1. Here, area of Z1 is equal to 1 by root 2 pi integral 0 to Z1 e power minus z square by 2 dz. Here the function pi of z, that is area of z1. Here in this area of z1, it is, we can take it as 1 by root 2 pi integral pi of z dz. Here pi of z is equal to, or simply we can take it as integral 0 to z1 1 by root 2 pi e power minus z square by 2 dz. So here we are taking pi of z equal to 1 by root 2 pi e power minus z square by 2. This is the function of z. This function is the standard form. It is the standard normal variate. So the definite integral, what we are taking, integral 0 to z1 e power minus z square by 2 dz is known as, it is known as the normal probability integrand, and gives the area under the normal curve between 0 to z1. This is known as the normal probability. Integrand, and it gives the under area between the 0 equal, z is equal to 0 to z equal to z1, then that area is called as the a of z1. From this only we can find out the areas. First we can check it, the lower limit value, upper limit value, where it is, and how we can find out the areas. Suppose for example, we can take probability of mu minus sigma is less than x is less than mu plus sigma. It is equal to integral mu minus sigma to mu plus sigma f of x dx. First we can convert into standard form. What is the standard variate? Z equal to x minus mu by sigma. Here sigma z is equal to, here we are taking lower limit and upper limit. Here x is, x1 is equal to mu minus sigma. Here we can substitute z1 is equal to mu minus sigma minus mu by sigma, plus mu minus mu get cancelled, minus sigma by sigma, it is equal to minus 1. In the same way, x2 equal to, we can take mu plus sigma, it is another variable z2 upper limit, that is mu plus sigma minus mu by sigma, mu get cancelled, sigma by sigma, it is equal to 1. So it is nothing but the probability of minus 1 is less than z is less than 1 is equal to integral minus 1 to 1, it is f of x dx, that is nothing but 1 by 2 root pi, sorry, 1 by root 2 pi e power minus z square by 2 dz. This is the integrand value. When here the limits, what we are taking here, the normal curve, this is the 0, z is equal to 0. Whatever the distance from the left side and right side, it will be same. So this integrand can be written as P of minus 1 is less than z is less than 1 is equal to 2 integral 0 to 1 1 by root 2 pi e power minus z square by 2 dz. From the 0 to 1 we are taking the normal table, normal distribution table. In this, z is equal to x minus mu by sigma. Here the table can be in the form of like this, it's 0.00 and 0.1, 0.2, like this. We can take 1.0 to this one. It is 0.3413 is there. That value substitute here. 2 into 0.3413 is there. It is equal to 0.6826. This is the value of in between of this. That is mu minus sigma to mu plus sigma. From that only mu minus 2 sigma to mu plus 2 sigma, that is the 95 percentage, and mu minus 3 sigma to mu plus 3 sigma, that is the 99 percentage of the confidence interval, that is under area. In this way we can find out. And one more thing here, area of minus z1 is also equal to area of z1. Why? Because it is symmetry and z is equal to 0 we are taking. Whatever the area is, the right side is there with z equal to 1. The same thing with z equal to minus 1, the area is same. If area is indicated with the positive sign, so we are taking area of minus z1 is equal to area of z1. Here some cases we discussed. How to find probability density of normal curve. Here just we can remember how we are taking the area. In the step 1, we can take first the probability that the normal variate capital X with the mean mu and the standard deviation sigma lies between two specific values x1 and x2, and with the relation of x1 is less than or equal to x2 can be obtained using the area under the standard normal curve as follows. The step 1 is we can change into standard form z equal to x minus mu by sigma. Find z1 and z2. What is the z1 means? Z1 is equal to x1 minus mu by sigma. Z2 equal to x2 minus mu by sigma. What are the values we are taking x1 and x2? From that we can find out the variate values z1 and z2. So in the second step, the general probability with x1 is less than or equal to x is less than or equal to x2, then that can be converted into standard form. Z1 is less than or equal to z is less than or equal to z2. Here, the probability area or the normal area can be calculated from the depending of the z1 and z2 values. If z1 and z2 both are, in this case one we are discussing, z1 is greater than 0, z2 is greater than 0. If both are greater than zeros means we can take, suppose z1 is greater than 0. Why? Because it is z equal to 0 and z2 is also greater than 0. How to find out the probability area means we have to calculate the area of this. So this total area is A of z2. This is equal to A of z1. So the probability of x1 is less than or equal to capital X is less than or equal to x2 equal to probability of z1 is less than or equal to z is less than or equal to z2. It is equal to area of z2 minus area of z1. You should remember if both are positive or both are negative also. If z1 is less than 0, z2 is less than 0. Suppose here it is z1, this is z2. How to find out area of z1 minus area of z2? This is the. And here we can take area of z1 and area of z2 means it is the modulus. Why? Because the difference is same, but here we are getting the negative, here getting positive. When we can take the modulus, then that is always in positive value. Okay, again, here find out the area of Z1, next find out the area of Z2, and difference of 2 is the what we require the area lies in between of Z1 to Z2. Either both are positive or both are negative values. Okay, next thing is in the case 2, if Z1 is less than 0 and Z2 is greater than 0. First, we can draw the figure. Z1 is less than 0. Why? Because it is Z equal to 0. Z1 is less than 0. Z2 is greater than 0. What we can require the area? This area. This area means that is the probability of Z1 is less than or equal to Z is less than or equal to Z2 equal to. We can calculate it is area of Z1 and this is area of Z2. The combined of the adding of two areas either side of the Z equal to 0, that is the area lies in between of Z1 and Z2. So we can write it as area of Z1 plus area of Z2. It is the second case. In the third case, in the step 1, two cases are there. In the step 2, the step 3. If in this also in the step 2 only, these are subdivisions to find probability of Z is greater than Z1. In this also case 1 and case 2 both are there. If Z1 is greater than 0, again we can draw the figure. If Z is greater than, this is Z, it is Z equal to 0, Z1 is greater than 0. From this we can calculate this area. We can calculate this area. How it is? The probability of Z Z1 is less than or equal to Z. That is the probability of Z1 is less than or equal to Z2, or simply we can take probability of Z is greater than Z1. That is nothing but the whole area is, this is 0.5. In this we can eliminate, we can subtract the area of Z1. Here you can take 0, it is, what is this? It's Z1 to infinity. In that case we can f of z dz. In that case we can take 0.5 minus area of Z1. It is the case 1. Next, case 2. If Z1 is less than 0, that is nothing but here is the Z1. So this area is also included. Means up to this area is 0.5. We can add the probability of Z1 is less than Z. Probability of Z is greater than Z1 here. Here probability of Z is greater than S. This is the Z value extends from the limit is Z1. So Z1, Z is greater than Z1, or probability of Z1 is less than Z. In that case, we can take 0.5 plus area of Z1. Case 2. In the another one, step 4. These are the subdivisions of the second part or second step. To find probability of Z is less than Z1. That is equal to Z is less than Z1 means, again we can draw the figure. Z is less than Z1. In this, Z1 is in the left side or Z1 is the right side. The total area is 1. In that, This z2 means that is integral minus infinity to z1 pi of z dz. This is the thing. Here the total area is 1. From the 1 we can take as 1 minus probability of z is greater than z1, or we can take from this means z2 z1 means 0.5 minus area of z1 when it is if z1 is less than or z1 is greater than. And here first we can take it as the probability of z is less than z1 means from this z is less than z1 whatever the value is, that is 1 minus of z is greater than z1, this area subtracted wherever it is. In this case 1, if z1 is greater than 0, if z1 is greater than 0 means this is the z1, so this area plus area of z1, so in this probability of z is less than z1 equal to 0.5 plus area of z1. Case 2, if z1 is less than 0, that is nothing but this is the left side of the z equal to 0. In this the probability of z is less than z1 is equal to 0.5 minus area of z. Just you can take where it is. These are the very important how to find out the area from the table of normal curve, that is 0 to x minus mu by sigma. From this only we can find out the problematic values and the area values.